Welcome to another rendition of Math is Easy Step by Step. I'd like to go over the negative exponents rule. I know I've shown you some examples in past videos. I'm feeling a little guilty I didn't quite introduce this to you earlier, but hey, it's never too late, right? It's never too late. So in order to change a negative exponent like 2x raised to the power of a negative 2 into a positive exponent, you must flip the term associated with the negative expression. So I'd like to show you an example here. I have that 2x raised to that negative 2 I originally started above. One thing I've done differently here is I've shown the invisible ones. I've shown the invisible ones. I'm not going to simplify this problem. If I was going to simplify this problem, again, I probably would want to show all of the invisible ones in this particular problem. Showing those invisible ones here in the exponents place for the 2 and the exponents place for the x, and showing that there is an invisible 1 underneath this 2x term. Now, you don't have to write these invisible ones. I do this for teaching purposes. So you can write a solid 1 there, a solid 1 there, and you can put this 2x over a solid 1 in the denominator's place. So in order to change that negative 2 and make it positive, I flip the term. 2x goes to the bottom, 1 goes to the top. That's what you see here. All I'm doing at this point is just showing you how to change a negative exponential power into a positive power of a power. Let's go ahead and take a look at some more examples I have here for you. Um, I always like to show you multiple ways to answer particular problems, and I will do my best to do that today. So here is example number 1, x to the negative 7th raised to a power of 3. And remember, when you have a power raised to a particular power, you can multiply these two terms. So I could take x to the negative 7 times 3 and multiply them together. I would get a negative 27. And then I would move forward the following steps. But I like to go slow. I don't like to get too advanced too soon. So all I'm going to do right now is show you that invisible one that's underneath this term. And I use a dot, dot, dot method. Now you can just, again, put the divisor bar and put that 1 underneath this term. There will always be a 1 under every term unless there was another number, 2, 4, 5, in the denominator's place, an x, a y, or z. But when terms are all alone, there's an invisible 1 underneath that term. And so let's go ahead and take a look. We want to flip that term. 1 will be on top. X to the negative 7 is going to be on the bottom. And what does that do? That makes that negative exponential power that we started with. Let me show you that here. That negative 7 now becomes a positive 7. Okay, flip it to make it positive. Now this is 1 over x to the 7th power raised to the power of 3. I could, and so to simplify it, 1 over x to the 7th power raised to the power of 3 means this term times itself, 3 times. So that's what I'm showing you here. 1 over x to the 7th times 1 over the x to the 7th times 1 over the x to the 7th power. What is 1 times 1 times 1? 1 times 1 times 1 is 1. And then remember, you can show those invisible ones here. You have 1 times 1 times 1 is 1x. And the rule is when you multiply, the base is the same. Keep it the same and add these exponents. 7 plus 7 plus 7 is x to the 21st power. So you have 1 over x to the 21st power is your simplified answer. And so I've got another example here. Here's another way you could have solved this particular problem, right? I like to show you more than just one way to do it, because in mathematics, I don't care what anyone has told you, there's always more than one way to solve a particular type of problem. And remember, power to a power, the rule is you can multiply. So here in the next step, I'm just showing you that negative 7 times 3. And in the next step, I want to make sure I'm showing you negative 7 times 3 is x to the negative 21st power. You show that invisible 1 in that next step. You flip that fraction, and now you have 1 over x to the 21st power. Okay, so again, there are multiple ways to solve the same problem. Okay, I hope you join me. I have a few more examples to show you regarding negative exponential rules. Math is easy if you take it step by step. Thank you for joining me.